Assalamu alaikum, dear friends and colleagues. To understand the operating principle of an air conditioner working with the vapor compression method, it is necessary to understand physical processes such as evaporation, boiling, and condensation. For this reason, we decided to explain these processes first, because knowing these processes deeply will allow you to easily understand what is happening inside the air conditioner, for example, why cooling or heating occurs. So, what is the difference between evaporation and boiling? Evaporation of water occurs at all temperatures. We all know that at 0 degrees Celsius or 32 degrees Fahrenheit, water is in a solid state, which is ice. Even in this state, some evaporation occurs. That is, the process of changing directly from a solid to gaseous state without passing through the liquid state takes place. This is called sublimation. Now let's heat this ice and see what happens. After a while, we witness the ice melting completely. After that, as we provide energy to the water, its temperature increases. As the temperature rises, we see that evaporation becomes more intensive. Finally, when the water temperature reaches plus 100 degrees Celsius or 212 degrees Fahrenheit, the water boils and the temperature no longer rises. Pure water boils exactly at this temperature at normal atmospheric pressure. Evaporation is a process that takes place on the surface of the liquid. The process of vapor formation throughout the entire volume of a substance is called boiling. Evaporation occurs at all temperatures, while boiling occurs at only one temperature at normal atmospheric pressure. As the pressure decreases, the boiling temperature drops. For example, on the peak of Everest, water boiled at approximately 70 degrees Celsius because the atmospheric pressure is low. To test this, we will now reduce the pressure over the water using a vacuum pump and see what happens. For this, I will use ordinary water, a jar, and a vacuum pump. Pay attention to how the water temperature changes in a short time. Dear colleagues and followers, as you can see, the water over a temperature of 40.4 degrees Celsius boils so intensely that some of the water inside the glass splashed out. When we immediately measured the water temperature, we observed that it dropped to 26.6 degrees Celsius. As water uses its own energy to boil, its internal energy decreases and the water cools down. Although boiling occurs in a vacuum at low temperatures, its intensity is relatively low because the pressure difference is small. Now let's cool the water a bit more and start our second experiment. We cooled the water down to 10 degrees Celsius, put it inside the jar, started our vacuum pump and observed the boiling again. A two-stage and powerful vacuum pump is needed to see more intense boiling. If you continue the vacuuming process, we will finally see poor water boiling at 0.01 degrees Celsius and turning into ice at the same time. This should be done in laboratory conditions with more advanced devices. For this purpose, I am presenting to you a video from the internet for education purposes. What you saw in this experiment was the triple point of water. At this point, water exists in the same time in solid, liquid, and gaseous form. So far, we have seen that when the pressure drops, the boiling temperature of water also drops. I should note that when the pressure rises, the boiling temperature rises. For example, if we increase the absolute pressure over the water by 1 bar, meaning creating a total of 2 bars of absolute pressure, we will see that the water boils at plus 120.2 degrees Celsius. So how does this process happen in cooling system, in refrigerants? Does their boiling point change like this too? Yes, it does. If we take R22 refrigerant as an example, we can say that it is in solid form at minus 160 degrees Celsius and its triple point at 157 degrees Celsius. That is, when the temperature is minus 157 degrees Celsius, R22 refrigerant exists in solid, liquid, and vapor form, just as we saw in the water example. If we slowly raise the temperature of the refrigerant, we will see that it evaporates intensely, that is, it boils at minus 40.8 degrees Celsius at atmospheric pressure. At normal atmospheric pressure, as in the water example, no matter how much heat energy we give to the refrigerant, its temperature will not rise until all the liquid turns into vapor. The only difference between the boiling and water boiling is the temperature. Now imagine that you have two devices, a freezer that cools down minus 40 degrees Celsius and air conditioner that cools down to plus 18 degrees Celsius. If both devices work with R22, how can the same refrigerant create different degrees in both the freezer and the air conditioner? What kind of miraculous refrigerant is this? The secret is in the pressure. We said earlier that the refrigerant boils at minus 40.8 degrees Celsius at normal atmospheric pressure. If we reduce the pressure in the suction pipe, we can achieve coldness even down to minus 60 degrees Celsius with this refrigerant, with R22. Theoretically, it is possible to get minus 150 degrees Celsius cold, but this is not technically efficient. In air conditioners, we must raise the pressure in the suction pipe with the amount of refrigerant and the power of compressor up to 5 bars. And now this refrigerant starts boiling inside the air conditioner at optimal plus 5 degrees Celsius or 41 degrees Fahrenheit. Dear viewers, we all know the impact of refrigerant on global warming. While preparing this lesson, we could have used R410A or R134A refrigerants for educational purposes to show boiling at temperatures below 0 degrees Celsius. But the GWP, global warming potential of these refrigerants, is very high. For example, this indicator is 2088 for R410A refrigerant. This is the damage caused to nature by 1 kilogram of R410A refrigerant released into the air over 100 years is equal to the damage caused by 2088 kilogram of CO2, carbon dioxide. Therefore, we decided to use R600 refrigerant, which has global warming potential of only 3 to demonstrate this process. R600A is a flammable gas. We decided to perform this experiment when the air temperature is 15 degrees Celsius, so that when we will take the 5 or 10 grams of refrigerant we need from the container, a large amount of gas does not go into the air. I should note that this experiment is conducted outdoors. There is no reason for a fire to occur around. This experiment is conducted for educational purposes only. Deep understanding of this lesson will prevent technicians from releasing thousands of tons of harmful refrigerants into the air in the future. Two thermometer sensors are placed inside a small container. One thermometer will measure in the Celsius scale and the other with the Fahrenheit scale, so that it is also clear for international viewers. The filming will be done in both normal and slow motion.
Now let's begin.
Dear colleagues, as you can see, an interesting evaporation phenomenon is observed in both the boiling process of water and refrigerant. So the only difference is in the boiling temperature. To make it a bit clear, I should note that iron boils at 2860 degrees Celsius and ethyl alcohol at 78 degrees Celsius. Now, let's remember once again that every boiling process is mandatorily accompanied by the absorption of heat. This is the reason why when the refrigerator is added to the conditioner is in gas form, the cylinder cools down. So refrigerant does not create cold inside the evaporator. It absorbs the surrounding heat as it evaporates. Because it reduces the amount of heat in the room, we say the air conditioner cooled our house. Coldness is actually the reduction of heat. So how much can we reduce the heat of our substance? In the universe, we know a temperature lower than 273.15 degrees Celsius is not possible. After boiling and evaporation are understood, let's look at the condensation process. We call the transition of a substance from a vapor state to a liquid state condensation. Every condensation is accompanied by the release of heat energy. In cooling technology, the place where this process takes place is called the condenser. In this part, the energy that the liquid absorbed in the evaporator while evaporating and the energy it received while passing through and cooling the compressor are released into the air. If the refrigerator inside the air conditioner is single component, the process occurs at only one temperature at a certain pressure, just like in the boiling process. That is, this temperature does not change until the last molecule turns into a liquid state. Dear viewers, in our next lesson, we will explain the operating principle of the air conditioner to you. As a teacher, I tried to explain the processes happening inside the air conditioner in the simplest language. If it is possible to explain in a simple language than this, I ask my colleagues to share their thoughts in the comment section. Don't forget to like us and subscribe to us. Thank you for watching us until the end.